As you can see, our lab is equipped with instruments to help with the learning. We have a range of instruments from digital multimeters, spectrum analyzer, arbitrary waveform generators, and oscilloscope. So this lab is equipped enough to handle courses at undergraduate level sufficiently. Most of the experiments are able to do it here very well.
Mugide Tabitha, a student at Soweto University, offering Bachelors of Engineering in Electronics and Computer Engineering, first year, second semester. What I'm going to present, I'm going to talk about the instruments we use in the electronics laboratory and the components we use to build circuits. Here we have, it is called a digital analog lab, where there is a breadboard mounted on it. It helps us to build electronic circuits, and the breadboard is used for joining the components together when we are performing experiments in the lab. Here is the programmable DC power supply. For it helps us to provide DC supply to our experiments. It can offer voltage or current, whatever you want to provide to this experiment. Then this one is a function arbitrary waveform generator. It is used for generating waveforms, which are viewed on the digital oscilloscope. The digital oscilloscope is used for just displaying signals. Then in this container, we have some components we use for building electronic circuits. Here are resistors, and they are of different sizes. A resistor is just used for resisting current. Then we have here potentiometer. Potentiometer is used for varying volume in our radio. If the current, it has a resistance inside. If the current is much, if the resistance is increased in the potentiometer, the current is low, so the volume will be low. If the resistance is low, the current will be high, so the volume will be high in the radio. Then we have a regulator. The regulator is used for regulating the amount of current which will pass in a certain component. If you have if you've supplied current from your power supply, which is 32, 5 amperes, yet your component needs 2 amperes. This one will help you to regulate that current so that the component gets 2 amperes. That is the regulator. That is the use of the regulator. Then we also have a transistor. The use of a transistor it acts as a switch and at the same time as an inverter.
Yes, I am Bongo Joshua, a student of engineering. I'm doing bachelor's in engineering in electronics and computer engineering in School of Engineering and Technology, Soweto University. So, in front of me here, I'm having a simple demonstration of Kirchhoff's law. Kirchhoff's law is one of the laws that we use under electricity in physics. So, as you can see in front of me, I'm having different components: the resistor, the connecting wires, the voltage source, and the instrument that can help me to measure the voltage and current. So, as we know from Kirchhoff's law, there are 2 laws. There is Kirchhoff's voltage law and there is Kirchhoff's current law. Kirchhoff's voltage law says that the algebraic sum of voltage in a closed loop is 0. So, as you can see from here, in this simple demonstration, I'm having 2 loops. There is the first loop, second loop, and the third loop which covers the whole thing. And the Kirchhoff's current law says that the algebraic sum of current entering a node is also equal to 0. So from here I also have my node which is connecting 3 resistors. That we call it an essential node. So if you look at this, if you want to know the algebraic sum of voltage in this loop, we need to connect this device. We call it a multimeter. It helps us to measure current, voltage, resistance, and other things that are involved in electronics. So if you want to measure the voltage across the resistor, what we do, we put the 2 probes, these are probes, we put them from one side of the resistor, and the other probe we put it on the other side of the resistor. This we call it measuring across. In voltage we measure across, and current we measure through. So if we put it this way, we can see that there is some value in our multimeter. Then that is for one resistor. Afterwards, we go and measure for the second resistor. In that same loop, we also measure for this resistor. We see that this resistor is also having some voltage. Then afterwards, we get these 2 voltages that we have measured from this resistor and this resistor. If we add them up, it will sum up to 0. That one is Kirchhoff's voltage law. Then for Kirchhoff's current law, we do it differently. In voltage, we measure across. In current, we measure through. So we would pick this resistor and disconnect it. After disconnecting, we measure the current passing through this resistor up to this node. After that, we bring this resistor back to this node. Then we measure the current also moving through this resistor towards the node. First displace it, then we connect wires in between them. Then we also look at the third resistor after taking this one back. We also measure the current passing from the resistor to the node. Afterwards, we add all those currents. If we add them, it must sum up to 0. That also proves the Kirchhoff's current law. So simply that is all about Kirchhoff's law. It's about Kirchhoff's voltage law and Kirchhoff's current law. As simple as that.
This is virtually testing what you have designed without the actual physical implementation. So this was what I did just in a rush. It's a speed control for fans. Showing speed control from speed 1 to 4. So after designing a schematic, you have to develop a PCB, or what we call the printed circuit board. So from the schematic, you come to this. This is the next step, as you can see. These are now the wires. On the PCB, we call them the trace or tracks. So this is the PCB design for the schematic that I've just showed. So in the design phase, this is the second phase. So after this design, go to the third phase to do a 3D visualization, that is 3-dimensional. This is how this PCB looks like in the beginning. So this is the actual PCB. After finishing the design and the implementation, this is how it will look like. It gets printed. These are the relays, then these are the LEDs displaying the different speeds for it. That's what I wanted to show. So the 3 steps from conceiving the idea, drawing that other schematic like this, then doing a PCB layout, this, then a 3D. This is how it will look like when it is printed or it's made.